Good afternoon, Prakash. Good afternoon, Mr. Prakash.
Hello, good afternoon.
Good afternoon, sir. So, welcome to the final day, final session, and it is happening like that. Like last time also, you are the person who was giving the lecture for the last session and was joining with us in the valedictory section also. So,
Thank you.
we are happy to say that it happened very well. All the experts have shared their experiences very nicely in all these 500 days, and we hope the audience will enjoy it. So we are waiting for a session. Let us wait for some time because the lunch time. So people
Yep.
will join back in the 5 minutes. Wait. Huh? Thank you.
Yeah, no problem at all. I'm here.
Thank you.
Even if it takes a bit more time, I'm happy to wait. I'm not in a
Okay.
rush. It is
Okay.
coming to 9:30 at night here.
Oh, so
So
sorry, we are disturbing you.
no. It's 7.5 hours ahead in summertime. Usually it is 6.5 hours in winter time. But like I said, I went to my son's cricket game today. He has got a
Oh,
couple of games tomorrow also. That's fine.
okay.
I'm not going anywhere. I'm happy to wait. Absolutely fine.
Thank you, Mr. Prakash. Thank you. Thanks a lot.
All good.
Shall we start?
So I think we can start. I mean, people are
Yeah,
joining, sir. Yeah.
yeah. Please inform, sir.
So Prakash, sir.
You just introduce about sir first.
Hello, yes?
So shall we start, sir? Is it fine?
Yeah, absolutely fine.
Okay.
When you're ready.
So good afternoon to everyone. So welcome to the last session of the STTP Phase 2 program. So I welcome Mr. Prakash Ramasubramaniam, who currently serves as a Senior Project Manager down in New Zealand. He did his diploma in Rail Transport and Management and postgraduate diploma in Business Operation. He also did his bachelor degree in Civil Engineering and AMIE and Masters in Transportation from the University of Auckland. He also done a various training program and reached to the high grade levels. Mr. Prakash is a chartered professional engineer and a widely respected contractors representative with over 30 years of experience in civil engineering. And he is predominantly in transportation projects, both overseas and in New Zealand. Over the past 10 years, Mr. Prakash has delivered many of Downer's road construction and rehabilitation projects for key clients such as Auckland Transport, Auckland Council, and the New Zealand Transport Agency. I welcome you, sir, for the session. I just hand over the session to deliver a topic of effect of material characteristic in terms and safety and performance of a highway. That's a case study.
Thank you very much. Good afternoon, everyone. I hope you can hear me clearly. Just
Yes, sir.
checking. Okay. Let's begin our session with a small prayer. Vakratunda Mahakaya Surya Kodi Samaprabha Nirvignam Guru Me Deva Sarvakaryeshu Sarvata Saraswati Namastubhyam Parate Kamarupini Vidyarambam Karishyami Siddhir Bhavatu Me Sada Guru Brahma Guru Vishnu Guru Devo Maheshwaraha Guru Sakshat Parabrahma Tasmai Sri Gurave Namaha. Good afternoon, everyone. I would like to thank you all at the beginning for this great opportunity to share some of my learnings with you. Today, it is going to be a little bit different from the last workshop discussions we had. I'm going to present a case study of how material characteristics, in particular skid resistance and geometric elements such as horizontal and vertical geometry, affects performance of state highways. When I say performance of state highway, it relates to the safety performance of state highways. So I will build a bit of a context and then we will take it further. Are you able to see my screen?
Yes, sir. Now you are presenting.
Okay. And are you able to see my screen right
Yes,
now?
sir. Yes, sir. Like
Yeah,
a map.
I will need a little bit of help as I go along. So please do help me.
Okay, sir. Fine.
Okay. Now this is New Zealand. It's got North Island and South Island, and also a small island called Stewart Island at the bottom, similar to Sri Lanka. There are no highways, luckily for us. Both North Island and South Island, as you see, is connected by a series of highway roads. And then in specific, today we are going to talk about State Highway 14, which runs between a place called Whangarei on the east to Dargaville on the west. The state highway is about 56 kilometers long, but notoriously having high crash rates. Part of the reason is the geography of the area itself. So if I click on the satellite version, immediately what you see is a green section. The dense area to the north is a forest area, but generally the terrain is quite hilly. When I say hilly, it's not like Kodaikanal or anything, but it is still quite steep with some series of curves. But some of the sections also have got long straights. Some of the straights are extending up to 4.5, 5 kilometers long. So early research have found that when you have got long straights followed by a gentle curve, the crash rate in those curves increases significantly to the extent of 20 times to 30 times. In part, it is to do with the driver expectations and the speed at which the driver is approaching the curve and the actual designated speed of the curve itself. So we found there were plenty of crashes happening in a particular curve or a distance of about 3 kilometers that suggested us to study a little bit more in detail. So based on this context, I'll also show you some pictures of the actual road itself. So are you able to see my screen now? I've switched between.
Yes, sir. It's visible, sir. Arrow.
Yeah, visible. So this is State Highway 14 for you. So as you can see, some of the straights which I'm talking are about 4.5, 5 kilometers long, followed by a sharp curve. As I keep going, you can see the road is in a very, very good condition, clearly line marked with end line, limit lines, as well as hazard markers, plus drainage channels on either side of the road. Seemingly, it is very safe, as you know, but yet the crash statistics have shown there are some significant crashes in some specific areas. So just to bring you all up to speed, when you see a double yellow line, that means you are not allowed to overtake any vehicle, slow moving vehicle. You can't cross the lane to the other side. And in particular, New Zealand finds a lot of overseas tourists coming here and driving in the New Zealand roads for the first time. They are permitted, but they may or may not know the rules. So here we go. After about 5 kilometers, you hit the first bend. So you are not expecting, even though it's a gentle curve, suddenly runoff road crashes increases in such bends. So I had the opportunity to study this aspect as part of a University of Auckland study. And there were some pretty good findings. So I will start my presentation now. Are you able to see my screen continuing?
Yes, sir. Yes, sir. You can
You're all
proceed.
with me? Good. So I have built a context of the case study of State Highway 14 and what is the methodology that was used, and then summary of the findings would be my presentation today. Background is it's part of University of Auckland research study. The sites were selected based on the crash research report, but they are not classified as CRS site. What we have also wanted to study in this is the influence of road geometry, skid resistance, and availability of clear zone. Clear zone is the distance that is available for vehicles from the edge of the road to the first hazard before they go run off the road. It is very challenging because of the geometry of New Zealand, which is quite hilly. There are very few plain areas within New Zealand, so it is quite challenging. We selected two sites, one in State Highway 14 and another in State Highway 12. Today we are going to discuss about State Highway 14. As I mentioned to you, there's high number of runoff road crashes resulting in serious or fatal injury. Each fatal injury costs about $4.2 million to the economy. That's life of every individual. State Highway 12 was an isolated curvilinear section with crashes resulting in minor injury, so we're not going to talk about that today. We also looked at some economic viability of treatment options because funding is very limited and the traffic volumes are also very low. So there is a cost-benefit analysis that needs to be done before you choose appropriate treatment options. And finally, we developed a methodology for analyzing high-risk, crash-prone areas. Road fatalities in New Zealand, it's shown in this figure. It's deaths per vehicle per capita. For 100,000 population, in the year 1950, it went as high as 25. It was hovering around that until 1970, where some serious efforts were taken to reduce the deaths. And three-pronged attack of education, engineering, and enforcement resulted in reduction of deaths, serious injuries, fatal injuries. And as you can see from 1972 onwards, it reduced quite significantly to current levels of about 5 deaths per 100,000 population. You must also take into account the population growth. Unlike some Western countries and Asian countries, population growth in New Zealand is very slow and very low as well. So the results are really tangible and comparable, but the efforts are still on to reduce the deaths in particular and also serious injuries in road crashes. Here is an example of crash reduction targets compared to some of the OECD countries where New Zealand is sitting. New Zealand target by 2040, road fatalities will be down to 200 per year, 2,500 hospitalizations. Currently, it's about 300. That is the target set and being worked. So we go back to our Northland example. I will pause this for a minute to show exactly where this State Highway 14 is in context to the overall map, and I'll show you some pictures before we go into some of the statistical research subjects. There's some difficulty I'm facing. Just give me 1 minute. Are you able to see the screen now?
Yes, sir.
Brilliant. Thank you. So this is the area where when you hit the curve, the vehicle used to run off the road pretty quickly. As you see, the speed limit posted is 100 kilometers per hour. But you have to drive to the conditions. And this is the area where the vehicle ran off the road and then resulted in a fatal injury, which is just 3 meters or 4 meters away from the edge line where high-speed vehicles are seen. Another thing to note is also surface. Surface only a 2-coat chip seal surface, what we call surface dressing in India, because of, again, financial best bang for the buck, and also correlating to the traffic volumes. Here it is a little bit better. That's another view of the crash site. Clear zone from the edge line through to before you hit the first object is very limited. It requires, for a 100-kilometer speed environment, you need about 9 meters. Here you see only 2 or 3 meters, which is pretty limited. This is another view of the crash site. So when a high-speed car comes through here and then suddenly find a sharp bend, they run off the road pretty quickly. Yeah, you can see the remains of some of the car leftovers. That's pretty much the picture of the site. So we'll go back to the presentation now. So here the context is, compared to the New Zealand statistics, how does Northland fare? It's very high compared to the percentage of fatal injuries, when the rest of New Zealand is about 3.8%. Northland in particular is about 7%, which is really, really high. That's what has prompted us to study what's the background. So here we go. The particular section which I showed you in pictures starts from chain age 1.3 to chain age 4.3. The key thing to note is a long straight followed by series of curves. And then the fatal area that I have shown is somewhere around here. Yep, similar pictures which you have just seen. You've seen this as well. So what we have done is we have picked up some crash analysis from the database, which is kept for the last 150 years. From the crash analysis report, what we found was between 2005 and 2009, there were 17 crashes. Out of 17 crashes, 13 of them were
மேனேஜ்மெண்ட் என்ன திட்டினா நான் ஷேர் பண்ணுவேன். அந்த
அது
டிபார்ட்மெண்ட்
personal.
விஷயம்லாம் வந்து நான் சொல்லவே மாட்டேன். அவங்களுக்கெல்லாம் எதுக்கு இருக்கு? அவங்க என்ன தெரியுமா சொல்லுவாங்க, நீ என்ன தெரியுமா சொல்லியிருக்கணும், நீ என்ன தெரியுமா சொல்லியிருக்கணும் வந்து நின்றுட்டு இந்த பீரோ படிக்க வச்சு.
Yeah, sir. Sorry for the interruption, sir. You can continue, sir.
No, that's all right. I heard some crosstalk, so I just waited. So out of 17 total number of crashes, 13 of them were loss of control. When you see loss of control crashes, that means it's attributed towards either geometry or surface skid resistance or weather conditions, or simply driver is either drunk or under the influence of drug or alcohol, or even fatigued sleeping drivers. So there is crash events are not single events, they are always chain of events. But we study run-off road crashes very closely to make sure whether it was due to any of the human factors or road conditions or vehicular factors, mechanical failure or similar. So we have this comparison year by year. Over the 5 years, there were 17 crashes and 76% of them were run-off road crashes. We also studied how the weather conditions, whether it happens when it was raining or whether it was dry. As you can clearly see, the rain or wet surface contributes to significant increase in number of crashes. Then we move on to look at the collision diagram at that particular intersection. The length of the road is about 3 kilometers, but the accidents are concentrated in some patches, as you see. Particularly this little red area here had high number of crashes, including 2 fatalities. So we've got economic evaluation manual, which predicts accidents depending on certain characteristics. Those are annual average daily traffic, called AADT, length of the road, exposure, and then couple of elements as BO and S adjacent. So if you work out the parameters there, crash rate as per EEM is X times BO times S adjacent, which worked out to 0.039, which means as per the model, crash rate should be 0.039. But the actual crashes experienced is 9 over that period, which is 5 years, which averages to 0.8. What it tells us is that particular intersection is 20 times more dangerous than what it should be. It is predicted to be. It's very, very high. So we studied few geometric parameters. Those are speed difference between successive elements and curve radius. What it means is if you have a long straight and a curve and then followed by another curve, we take that speed difference between successive curves. So on the left hand side, you see a plot of curve radius anywhere between plus 350 to minus 350, which means left-hand side and right-hand side. That's simple distribution. And also plotting the speed difference. So between the chain edges, 1880 to 4.3 kilometers, or 1.8 to 4.3, which is study area of about 3 kilometers, you see there is some significant difference between individual curve speeds. This sort of pattern also does not help. Then we studied another important characteristic, which is approach speed and the designated curve speed to horizontal curvature. Horizontal curvature is 1000 divided by the radius of the curve. 1000 is a constant number. So we plotted the horizontal curvature from 0 to 8 on one side, or 0 to minus 8, compared to the speed difference between approach speed and the curve speed. We looked at anywhere between 0 to 4, plus or minus 4 would be safe window. However, we found a couple of areas, particularly 2670 to 2860, which is about 90 odd meters, or sorry, 190 meters, had a very high speed difference of 35 kilometers per hour. So please note these sections, because there is a correlation that is coming. Then we also looked at factor of safety in these crash locations. A factor of safety of at least 1.25 is considered, 1.25 or above is considered to be safe. So in those particular sections, what we found is the factor of safety is below even 1, which means safety is compromised in those areas. And without any surprise, you see a lot of those crashes are also assigned to that area. And this particular area had a fatal crash site. Then we looked at the crossfall and design superelevation characteristics, and then mapped that to see if there is any major difference. Finally, we compared the radius, the actual radius present, to R minimum and R calculated, depending on the departure speed, and then saw if there is any major variance. And sure enough, we found the location in question was deficient in its geometric horizontal curve, I should say. Then we move on to what is called a scrim chart. Scrim is basically a measure of skid resistance or surface coefficient available for friction. And then these surveys are done annually to see if the road has undergone any significant surface deterioration. If it does, below the threshold value, then section will be selected and it will be resealed. We found the intervention levels are between 0.4 and 0.7, which is pretty standard. There isn't any great deviation. Then we found friction versus skid resistance. We measured the F demand, what is the friction coefficient that is on demand, and then mean scrim value or available friction coefficient, and then found in that crash location the difference is very, very small between the demand and actual, which shows us that that area has got sufficient skid resistance. However, it is due to the geometry that it is failing. Then we moved on to do some economic analysis to do some improvement works based on low cost improvements or high cost improvements to have reduction in accidents. So the provisional BCR of 6.21 with a 50% reduction in accidents, but spending $1.45 million seemed to be very high compared to a medium cost or a low cost improvement, which will reduce the number of accidents. But the target is to go until 50. Then we did a little bit work on the incremental BCR to see we will do work over a period of time. And we ran a sensitivity test to see with the cost capped at $1 million, what would be the BCR that we can achieve. In summary, what we found is road geometry, in particular, long straight followed by a curve, and the approach speed into the curve to the actual curve speed, skid resistance, and the availability of clear zone all contribute to compromising the safety or safety performance of the site of the highway section. We concluded that significant crashes were concentrated in that 2400 to 2.8, 2.4 kilometers to 2.8, 400 meter section, which had some significant geometric deficiencies that needs to be corrected. Based on this study, work has been done. Those curves have been realigned. Although the incremental PCR justifies geometric improvements, it was taken seriously, and then those improvements were done in the following years. Providing clear zoning in this section will also reduce severity of injuries. So when you've got, instead of 3 meters, if you have, say, 6 meters of clear zone, once the vehicle runs off the road, they have opportunity to correct itself and come back again on the road. And if it results in injury, the severity of injury will also reduce. Crash barriers or similar elements, safety elements could also help. So based on the research, we developed a methodology that combined geometric analysis and friction demand with the existing high-speed data survey that we do every year. And then we have developed that methodology. First, we identify a project location based on crash study and high concentration of crashes. We look at the crash analysis, and then we compare the actual crash rate versus the EEM prediction model. Earlier in the presentation, I mentioned to you the State Highway 14 particular crash location was 20 times worse than the prediction model. The prediction model value was about 0.039, whereas the actual found was 9 crashes, which means 0.8. If the actual crashes is less than the prediction, then the road is fine. But whereas if that is not true, then we need to make further analysis. In our case, it was 20 times worse, so we went to the right side. So when we go to the right side, what sort of analysis we can do? Firstly, the road geometry, and then friction, the friction resistance over the last 5 years, how the deterioration is seen, and finally, working out an economic value. Carrying on. Within the road geometry, what are all the characteristics that were to be studied? Firstly, we check the radius. R minimum and R calculated for design speed. In this instance, the the posted speed limit is 100 kilometers an hour. The design speed will be 120. R minimum compare with R actual. What is the radius available actually? And see if there is any significant difference. Check the speed, geometrical consistency, and also compare curve speed to approach speed and the horizontal curvature. Also check the super elevation. Some of the areas it may be deficient. What you find as E actual to E design, and see if there is any improvement is required in the super elevation. So to put together again, identify the project location, do all this analysis, and then put them in the geometry area, and compare the friction demand with measured scrim values and the friction, and also comparison of various treatment options under economics. Thank you. That's my presentation today to advise you that highway safety is reliant heavily on the geometric elements and also skid resistance of the surface, which is the surface characteristics. The skid resistance deteriorates over time. It never improves. But with some good maintenance strategies, this can be monitored and then upgraded before any major crashes, fatalities, increased number of fatalities happen. Especially in high-speed environments, it's important to keep the road maintained regularly. I hope the presentation was useful and you all enjoyed. I'm happy to take questions.
Thank you, sir. It was a nice session. So participant, do you have any question? You can just post your question in a chat box. Or you can even unmute your mic and you can directly ask your question.
Thank you, sir. It was a very nice session.
Thank you. You're welcome.
Case study you have presented. Very good. Thank you.
You're welcome.
Thank you, Prakash, for the presentation. Thanks a lot. This is Rajan. Thanks a lot.
Yeah. Oh, thank you. You are welcome, Rajan.
Dr. Karthik, thank you, sir.
You're welcome, Dr. Karthik.
Prakash, this is Shaktivel.
Hello, Shaktivel. How are you doing? Dr. Shaktivel?
Yes, fine. It was a very nice presentation.
Thank you very much, Shaktivel.
Right.
Good to hear you.
Nice. I never miss you.
Thank you.
Officer James. Impressive to be the name tag.
Good night, Prakash. Kishore Kumar.
Hello, Kishore Kumar. How are you?
Nice presentation. Good to see you.
Thank you. Nice to see you as well. Nice to hear from you.
So, Shobana, you can announce the participants to post their questions. Prakash can share anything else. In addition to the presentation, also you can share if anything specific the participants want to know from him, because there still time is there. So you can parallelly share the feedback link, and the participants can also put forth their questions to the speaker of this session. And then you also announce about the evaluation test, the very important part of the program, please. Shobana, you have to take the mic now.
Yes, sir. Sure, sir. Thank you, sir. So participant, as I mentioned earlier, you can even unmute your mic and you can ask directly question to the sir so that he will clarify your queries. Meanwhile, the feedback link has been posted in the chat box for this session. So you kindly fill your feedback.
And Shobana, please remind about the evaluation test. I told you no. Followed by, yeah.
Yeah. So after finishing the session, you will have a validity test. That is, it will be shared in the link.
Well,
So you have-
evaluation test. Evaluation test.
Yes, evaluation test. It will be having some questions. So we will be sharing that link too. So kindly see that link and you just answer the questions after the session is over.
Shivaraj, better you communicate, clarify things like for getting the certificates, what they have to do. Like Shivaraj,
Yes, sir.
you clarify the participants what to be done. How many questions will be asked? What they do? It is a final feedback session. No, please tell all those things, please. Start telling.
Participants, sharply at 3:15, you will the evaluation and validatory session will start. At the end of the session, we will send a feedback link in which 30 MCQ questions will be given. After answering the questions, you will get the certificate.
And that is nothing but a final feedback form, which in which you have to answer the generic questions regarding the 6 days program. The whole 18 sessions went off with a lot of experts, and followed by there will be some 30 simple, very very simple questions. And don't worry, it's just a simple evaluation test. Nothing to worry. Please answer that, and once you do it, automatically the certificate will be generated and it will reach your mailbox. That is the way it has been set. The mechanism has been set. And if you want to have any questions not related to the presentation now given, even in general, you can ask anything related to highway and transportation, because Mr. Prakash is an expert in highways and transportation for more than 30 years, both in India as well as overseas. And presently, he has settled at New Zealand, and he is now a New Zealandian. And he is also a very good cricketer. He is an expert cricket coach, and his son is an excellent cricket player there. I hope so. He will become an international player in the very soon future. And he initially itself said he had been from the ground, now directly here to give the session, and now after sleeping he will be going to again to watch the match which his son is playing. And the additional information which I give you now is he is a professional coach who is a trained coach in cricket who is eligible to even join international cricket. That is what is my understanding. It Prakash to clarify these things, and you can even ask any questions that it is not only a technical session. You can clear any doubts in cricket also. He is an excellent cricketer, player as well as a coach. This is what I want to share about Prakash. I hope nothing wrong in this, Prakash.
No, I think I'm flushing here. I'm blushing here because of I don't know. I'm a qualified coach, definitely. Yes, I agree. I coach young children here, age group cricket in New Zealand. I'm a level 2 qualified coach. Yes, but it's just something that I can share. I'm not coaching at higher levels. It's just young and budding cricketers. When they start, I teach them the basics.
Thank you, sir. So, Prakasha, there is one question. Can you able to see in the chat box, sir? The question is from Mohit Kumar.
Mohit Kumar, he asks, I would like to ask about the monitoring system of skid resistance. So, Mohit, can you expand it a bit more, please?
Mohit Kumar, if you want, you can unmute your mic and you can directly speak to sir.
Is there any continuous monitoring of skid resistance ongoing?
Afternoon, sir. Prakash, sir. Yes, sir. So there is a wonderful presentation. So I would like to ask, how is the skid resistance can monitored continuously? The
Okay. Same question Kishore Kumar has also asked. There is no continuous monitoring. It is periodicity. So once a year, there is a equipment called scrim equipment, that skid resistant measure, moves around the country in a high speed environment and then takes the road characteristics, including skid resistance, available friction coefficient when it is run. I will try to get a picture of that scrim equipment, and shortly I will present it here. So it has to be done in a periodical way. So once a year, the equipment keeps moving from one end of the country to the other end of the country, and they monitor. Obviously, they find the friction coefficient available, and then compare it to what it was previously. And there are some intervention level thresholds. So as you know, if the threshold level is very low, then more frequent maintenance will be required. But if the threshold limit is higher, then obviously you will have less intervention levels. So usually it is kept at around 0.55 as a minimum, after which you need to intervene by providing appropriate treatment. If it falls below 0.55, that means we have left it to deteriorate further. Naturally, your crash statistics will also increase. There is a correlation between that as well. But if the threshold is high, for example, 0.7, if you start intervening with the road, then the cost of maintenance will also correspondingly increase. So you need to find a balance between how much money you have and adjust the intervention levels. I will try to find, if I can find the scrim machine. Just give us a minute.
So participant, you have few more minutes to end this session. So if you have further queries, you can just ask. So the next session will be an evaluation session, that is a validity session.
Shobana, ask Shivraj to post the links of feedback sessions of
Okay,
today's session 1 and session
and
2
two.
also in this same chat box today.
Yes, sir.
Not in
It's
the
been
not
posted.
yeah not now.
Yes, sir,
Session 3
now it's
now.
posted.
Yeah, session 3 you have posted. Also post session 1 and 2 of today in the chat box, so that if somebody has missed, they can do it. Then also as a bonus, present the session link. Ask Shivraj to present the session links of the earlier days, all the 5 days, in the chat box only, not in the
Okay.
WhatsApp, so that we can bring in people at least now for the valedictory notes, those who have missed due to various reasons, due to their academic and other works. let us give them a chance. Let them come to the here, into the our Google Meet window. So ask him to post all the links day 5, day 4, day 3, day 2, and day 1 also continuously in this chat box, so that people can utilize it if they missed it. Okay.
Okay, sir.
And then by 3:10, around 3:10, 3:05 to 3:10, you can start giving the link of evaluation test, which will take at least 10 to 15 minutes for them to finish up. So sharply at 3:30, we'll start and end the valedictory note. Dr. Shaktivelan sir will be giving the valedictory note for the program in this end of this 6 days SCTP. I have already requested him, and sir is already available.
Okay.
I hope all the participants have enjoyed the program, and I hope all the participants to join with us in this ending session, and give their feedback, not only through the forms. We request you to also provide your feedback through raising your voice by unmuting your audio. We'll be very happy, because it has taken a lot of effort to arrange these things, and the only thing which should motivate us to do these kind of programs again and again is your appreciations and your your feedback. So please understand and encourage us. Thank you.
Yes, sir. Sir, Rajan sir?
Yes,
Dr. Rajan.
yes.
Yes, sir. The participants are frequently asking about the PPTs from
that please.
That would be mailed, it seems.
Yeah, I will inform now. So PPTs we are collecting from all the experts. We are not trying to send it in a piecemeal, like one is sent, another is not sent. We don't want to rush and send it. We are collecting everybody's presentations, including the last presenter, that is expert, Mr. PRAKASH Ramasubramaniam presentation. We'll club everything, all the 18 session presentations, we'll club together, make a file, compress it, create a link, and then we'll share that link to your email IDs as well as the WhatsApp groups which we have formed. Additionally, we will work for 2-3 days and edit all the videos, removing all the disturbances kind of things, and the clear video with good clarity of all the 18 sessions will be available for you in public, which is now in private in the YouTube channel of mine, that is in Rajan Academy. So it will be made public to all of you, and the link will be shared to you in another 48 hours. I hope Shivaraj is the person behind it. We have to thank him. He will do it, and it will be shared. That link will also be shared, so that those who have missed some of the experts' talks in these 6 days can always go and click the link and can and you can get exposed to what and you can get the knowledge dissemination of that particular topic in this STTP program. So I think I have cleared the doubts of participants' queries, Shobana. Okay.
Yes, sir. Thank you, sir. Thank you, sir.
And I'm very happy to see we all are good friends, a team of friends, Mr. Prakash, Dr. Shaktivelan Ramachandran, Dr. Kishore Kumar, and myself, Dr. Rajan, all are good friends for a very long time, and all have grown as civil engineering professionals, and we all are now the same forum. And Dr. Veeraravan was our mentor, guru, and a professor at IIT Madras. He only almost he framed this schedule, the whole program. So I have even requested him to join here if he is free. Let us see whether he could join us. I think he is busy with the parallel program is going on. If he is free, he will come and join us also. And Dr. Shaktivel will give a few words, and I think this program will then come to end. We'll wait till the evaluation test is over. Please, all of you, take the evaluation test and see how much marks you take. And Mr. Srinivas is there. Has he joined? Mr. Srinivas sir is there. Srinivas sir, he has joined here.
Sir, I saw his name, sir, but I'm not confirmed whether this is present.
Yeah, we will see. He will also join. I have requested him. He will join. He is our well-wisher who talked
Shobana?
during the last STTP also. Somebody is calling, Shabana.
Yes, sir. Yeah.
Somebody is
Shobana,
calling, please.
Dr. Karthik calling. Just one doubt.
Yes, sir.
The PPTs will be shared, shared through YouTube, madam.
No, sir. We will be sharing through mail ID, sir. Actually, we are collecting from all the resource persons.
Registered mail ID.
Yeah, sir. Your registered mail ID.
Mail IDs which we give in the feedback link.
Yes, sir. That's the mail.
So in that mail ID, you'll share.
Yes,
It
sir.
will be shared on the mail, madam.
Yeah, sir. How we get, we will be sending
The-
to as a
sort of
PDF
zip
or a
file,
PPT.
ma'am.
Sorry,
Sort
sir.
of a zip file, ma'am.
Yes, sir. Dr. Karthik sir has just now said, once all are sent, all the 18 experts PPTs will bundle together and it will shared as a zip file. That's all.
Zip file.
Okay.
Okay, thank you, sir.
Yes. And additionally, video links will be shared.
I was not able to hear clearly.
Yeah, now are you able to hear?
Yes, sir.
Yeah.
Yes, sir.
Thank you, Dr. Karthik sir. Thank you.
Okay,
Thank you,
sir.
sir. Thank you, sir.
Test link around 3-5, I think. Shivaraj, 3-5 you can share the test link. So that people will take 15 minutes to finish it.
Okay.
Sure, sir.
Thank you.
Prakash
Thank
sir,
you.
thanks a lot. I
you.
think,
Thank you,
can
Robert.
you stay or it is late night already for you? You want to say good night? You want to say good night?
Yeah, I have to leave. It's already 10:30. So
Yeah.